Good morning, everybody. And it's a Saturday morning. And this morning I would like to talk about binary compounds. Binary compounds, I guess you could predict, are compounds. That's how I abbreviate compounds, okay? CMPD is compounds. Binary compounds are compounds formed between two elements. I imagine you predicted that because binary means two. What gets a little complicated in the naming of binary compounds is there are two types of binary compounds, and the nomenclature process starts with us identifying what kind of binary compound we're working with. So I'm going to put up two binary compounds that might look familiar. We have a sodium chloride, and let's try this. Carbon and an oxygen. That's called carbon monoxide. Now let's just think for a moment. We say sodium chloride and we say carbon monoxide. Do we say sodium monochloride? We don't, do we? And we don't just say carbon oxide. So the nomenclature procedure for naming these two different binary compounds stems from the fact that they're made up of different elements. So let's look at these. Okay, now I've started this Explain Everything this morning about 4 times because I was resetting how my pen works. So let's see if I have it exactly sensitive to my particular pressure on the end of the pen. In the sodium compound, in the sodium chloride compound, can you tell me by looking at the periodic table what's unique about the sodium chloride compound versus the two elements that are used in the carbon monoxide compound? So I'm going to give you a little moment. And as we talked in class, when I pause on the Explain Everything videos, it's your time to jot down on your notes what is the answer, and then you can have immediate feedback. So I'm going to give you a moment to try to come up with an explanation as to why the binary compound between sodium chloride is different in the naming of it than it is with the binary compound carbon monoxide. So I always hope you have the periodic table out. So if you notice that the sodium was a metal and the chloride came from a nonmetal, versus the carbon and the oxygen in carbon monoxide are both nonmetals, you found the answer. We name compounds made between a metal and a nonmetal differently than we name compounds that are formed from two nonmetals. So in naming, we have to first identify whether we have a binary compound made between a metal and a nonmetal, or whether they're made by two nonmetals. So let's start with the binary compound named between a metal and a nonmetal. The first thing we do is we recognize that the metal version is the positively charged material and the nonmetal is the negative. We have names for these. This is a review, I assume. So the positively charged part is called the cation, find the negative part of the binary compound made between a metal and a nonmetal. The negative is the nonmetal, and that's called an anion. Whoa, anion. Get that? Huh? My pen is better than it was earlier today, but it still is not perfect. But I'll get there. Okay, so oftentimes the binary compound made between the metal and the nonmetal is also called an ionic compound. And the way we name ionic compounds is we always put the cation first, and the cation we just say the unmodified name of the metal that it stemmed from. So in this case it comes from sodium, so we just write sodium. The anion name in an ionic compound is where we have to start to think about endings, like conjugations in a foreign language. So we have a subset on anions when we go to do nomenclature of ionic compounds. In this case, our chloride is termed monoatomic. Now, monoatomic is exactly what it says. Mono meaning one, atomic meaning, of course, atom. So monoatomic ions have a certain ending. And the ending in monoatomic ions, anions that is IDE. So whenever you hear "ide," like chloride, oxide, bromide, nitride, you know then it is a monoatomic anion. The prefix in this case is chloride. So we have it coming from chlorine, but it is not chlorine because chlorine has zero charge. It is chloride. So to say this compound's name, we say sodium chloride. So let's try another one. Let me see if I can move my screen up a bit. That makes it smaller. Ooh, I'm learning something. Here, let's try this. Oh, that still makes it smaller. All right, skip it. I want to do another one. We'll choose blue this time. Remind you, we're still under ionic compounds. All right. Let's try, ooh, it's not even writing anymore. What the heck? Here we go. I bet I can do it now. Yep. How about this? That's another binary compound, isn't it? Let me give you a chance to know why it is a binary compound. Whoops, that's interesting. See what I just did? I was able to pick up and move. Learn something new. Okay. So you noticed barium is on the metal side of the periodic table. So we know that this is a metal. We know that the oxygen is a nonmetal. And that tells us how to name the compound. That tells us that we, in order to name this, our metal name is the unaltered elemental name, barium. And our nonmetal is monoatomic in this case. meaning it's only made up of one atom. And so I know I'm going to have an IDE ending because it's monoatomic. And to describe that it's actually originating from oxygen, I have ox as my prefix. So the name of this compound is barium oxide. Now I challenge you to do a couple on your own. Mind you, these are all ionic compound binary compounds. Ionic compounds. We're going to do binary compounds that are made from both nonmetals on a different video. So I challenge you to try to find in your textbook or on the online book in OpenStax chances to practice naming ionic compounds, compounds between a metal and a nonmetal. Plus you can get familiar with where these atoms are on your periodic table. So I hope this was helpful, and I will see you soon. Have a great day.